I will be doing problems from Chapter 3, Section 1 using the definition of derivatives. This will be number 9. So we're going to use definition number 1. So let me go ahead and do this. This says just take your original function. So I'm going to take that and copy it down. Minus, this says place a into the function and subtract it. So make sure you put it in parentheses because you have to subtract all of that. So that negative needs to be distributed. All over x minus a. And real quickly, if you put a here, that's going to be 0, that's going to be 0. So 0 over 0 is indeterminate. Excuse me. So you need to factor and cancel or do something different. So what I'm going to do is distribute the negative here, and I will get minus a squared plus 5. And what I like about this, these will cancel. And then I get x squared minus a squared over x minus a. I'm still in the same boat. X is approaching a, so if that is a and that is a, I get 0 over 0. So I still have to factor and cancel. So the top is the difference of two squares, so it becomes first minus the second, first plus the second. And now I smile because now I can cancel. And now I have the answer. So as x approaches a, you replace that with an a plus a is 2a. So that is the derivative at the point a, and you could rewrite this at x. Same thing. So f prime of x is 2x. Now there was a second part to this, so I am going to eliminate this to give me some room. We wanted the equation of the tangent line. Well, we know, or you should know, this is the equation of any line through point x1, y1 with a slope of n. You have to know that. They give you x1, y1 right here. This is x1, y1. They're nice like that, and they give that to you. So how do you find the slope? You should say the slope of a tangent line is the derivative at that point. So I take the derivative at 3. And you might say, why do I plug in 3 and not 4? Because this function says you use x. So we found f prime of x down below is 2x. So f prime of 3 is 2 times 3, or 6. I'm pretty much done. The 3 goes in for x1, the 4 goes in for y1, and the 6 goes in for the slope. And there is your equation of your tangent line. Done. Here goes number 19. So we are going to use definition number 2 this time, they ask us. So how do we do this? Well, this thing says plug x plus h in for x. So I'm going to get x plus h squared minus 4 minus, and it says take away the original function, which is that whole thing. Since I'm subtracting the whole thing, make sure you parenthesize and subtract the whole thing over h. Now, if h becomes 0, that's 0. You get x squared minus 4 minus x squared minus 4. You get 0 over 0. So we know we have to factor and cancel. So we're going to simplify all this. So we are going to square that. I didn't mean to do that. We're going to square this. And when you square it, it's not x squared plus h squared. It is a binomial squared. You have to FOIL that. It comes out to be x squared plus 2xh plus h squared with a minus 4. I will distribute that negative sign, minus x squared plus 4 all over h, and beautiful things happen. X squared minus x squared, bam. Minus 4 plus 4, bam. We are almost there. So I have 2xh plus h squared over h. And we still get 0 over 0 when you plug in 0 for h. So we have more factoring and canceling to do. And if you look at the top, they both have an h. We need to take that common factor out. And bam, those h's are gone. That's approaching 0, so the answer on this one will be 2x. Hey, and guess what? The previous one was also 2x, same derivative. So f prime of x is 2x. Now I will go ahead and talk about the slope of the tangent line again. It's the exact same thing. You might want to just fast forward through this if you already know how to do that. Let me delete that. So the slope of a line is this, or the equation of a line. This is any line with a slope and a point. I'm given x1, y1. They were nice. What tells me the slope of a tangent line? And simultaneously everybody says the derivative. So where do I want the derivative? I want the derivative at the point of tangency, which is this point, but the formula uses x, so I'm going to use a 2. It's 2 times 2 or 4, and I am done. My answer is that. What did I do? This is x1, bam, y1, bam, and the slope, bam, done. Okay, number 26. I don't think this was part of your homework, but I did it because it's fun. We're using definition number 2. It's actually kind of ugly, but we're going to do this. So the first thing they want is plugging this in for that x and that x, replacing the x's with x plus h. Minus the original function, so I just copy that down. All over h. Now, you've heard me say this multiple times. I don't like a fraction in a fraction. So I clear that by multiplying by 1. And my 1 is going to be the common denominator over the common denominator. Now, beautiful things are happening as we speak. When we distribute this to this, the x plus h plus 1 cancels, leaving the x plus 1. So let me copy that. We already had an x plus h, and now we have an x plus 1. When I distribute these, the x plus 1's cancel, leaving an x and an x plus h plus 1. So minus x and x plus h plus 1 all over everything on the bottom. I need to clean this up, so I need to factor the top. The bottom's already factored. We're good at that point. But I need to factor the top. So on the top, I don't see any common factors. That term and that term, there's nothing in common. So the only way I'm going to have any success is to multiply that out, and combine like terms. So if I do all the distributing here, I will get x squared plus xh plus h minus, and okay, I have to distribute this to all three, so I'm going to get minus x squared minus xh minus x. And now I am very pleased. X squared minus x squared, gone. X minus x, gone. Xh minus xh, gone. That is so beautiful. So what do I have? Oh, the bottom, all that stuff is still there. Now, on top, all I have left is an h. That's an h, by the way. And I think you already see it, because I see it. Bam, look at that. So Nice. And this is going to work out so nicely. 1 on top, x plus h plus 1, x plus 1, and we know that h is approaching 0, so that becomes 0, and we have x plus 1 squared on the bottom. X plus 1 squared. So that is the derivative of that. I'm not going to find the equation of the tangent line. I did on the 2 previous problems. It's the number 31. We are going to find the derivative. We have 2 different ways to choose from. I am going to choose definition number 2 here. And here we go. Well, this says replace, hold on here, let me write the limit part. Replace x with x plus h. That's easy. 1 over radical x plus h minus the original function, which is just 1 over radical x over h. The problem here, I don't like when we have a fraction inside of another fraction. I get rid of it by multiplying by 1, and that's going to be the common denominator. So there we go. And so when we multiply this, we will get this. This distributed, the x plus h's cancel, leaving just radical x. When we distribute this one here, the radical x's cancel, leaving x plus h radical, minus radical x plus h. And the bottom, everything just stays. We don't multiply the bottom out because that would make it unfactored, and we want factored. Now, if you plug in 0 here, the bottom 0, 0 here, that will get 0. That's indeterminate. So I need to multiply, and I got to get some space here, so I'm going to rewrite this. I need to multiply by the conjugate. And that is a minus. So what is the conjugate? It's going to be radical x plus h. But if I do it on top and bottom, I'm actually multiplying by 1. And I learned in 3rd grade that it's still the same thing. So now the bottom has a lot of stuff. H, radical x plus h, radical x, parentheses, radical x plus h. All that's on the bottom. Don't multiply it. You're trying to get it factored so you can cancel. Multiplying unfactors. Factoring is the backwards multiplying. So on top, you need to make sure that you distribute correctly. If you do all that, you end up with x minus parentheses x plus h. And we'll get our next line. Distribute the negative on top, and you get that. And the bottom all stays the same. There's a lot of stuff there. The x's on top will nicely cancel out. And then the h on the bottom and h on the top leave a negative 1 on top. We are almost there. So the derivative is the limit as h approaches 0. The top is a constant, negative 1. Well, that becomes 0. We get radical x, another radical x, and in the parentheses, radical x plus radical x, again because that's going to 0. I need some room. I'm going to move this thing out of the way. And here we go. Radical x times radical x is just x. And actually, I don't even need this limit because I just took the limit. No necesito. Negative 1, that's going to give me x. And a radical x plus a radical x, that gives me 2 radical x's. Now let me rewrite this. That's x to the first. I'll put the 2 in front. Square roots x to the 1/2. You learned, you add these exponents so that we get our beautiful answer of negative 1 over 2x to the 3/2. There is the derivative for that problem. All right, we are going to move to 33. We've got a couple more to go. I'm going to eliminate this to give myself some room. And I'm going to move this up. All right. For 33, we're going to find the derivative of this. You have two formulas to choose from. Which one do you want? I will just choose the first one because we haven't done that in a while. F prime of a is the limit as x approaches a of f of x minus f of a over x minus a. So this process to start with is not so bad. I'm going to plug, well, this is just the original function. It's that. So radical 2x plus 1 minus, then it says plug in a here. I will plug in a. It's radical 2a plus 1 all over x minus a. And as we see here, as x approaches a, that's going to become an a, and that's 0 over 0. So the technique we've used over and over for this is multiplied by the conjugate. Let me scoot this over to give me some room. So the top and bottom I'm going to multiply by the conjugate. That's going to be a plus and plus. And so here's the next line. Remember, you do have to distribute like that on top. If you do that, you should get 2x plus 1 minus 2a plus 1, and those should be in parentheses. And the bottom is just everything that we had. And I repeat, do not multiply this. You do not want to unfactor the bottom. You want to leave it as it is. All right. Well, the top, let me distribute this negative here. I'm going to get minus 2a minus 1. So what are we left with? The 1's will cancel. So those are gone. And my next line will be this. 2x minus 2a. And the bottom is all still there. And as I'm talking, if you plug in a for x on the top and the bottom, you will get 0 over 0. Indeterminate. Well, I'm just going to factor and cancel now, because I've already multiplied by the conjugate, so I'm not going to do that again. But the top has a common factor of 2. Oh my, that is so beautiful. So beautiful, because now x minus a is cancel, and we are done. F prime of a, the top is 2. This is approaching a, so 2a plus 1 plus 2a plus 1 is going to be 2 of those. So in the bottom we're going to have 2 radical 2a plus 1's. And then these cancel and leave 1 over 1, which gets us 1 over radical 2a plus 1. There is your derivative. That's number 33. Now we're going to go to 37. Apparently I've chosen definition number 1, and this is going to be a pain in the buttocks, but that's okay. Last one. This says take your original function. I can do that. 3x squared plus 2x minus 10. Then it says plug a into your original function. And you're subtracting that whole thing, so parenthesize it, please. All over x minus a. And as usual, if you let x approach a, that's going to be 0 over 0. So we need to factor and cancel. So on top, I'm going to distribute. There's a 1 there you don't see. So I distribute the 1, which doesn't change anything. But then I distribute the negative, and we get this. 3x squared plus 2x minus 10 minus 3a squared minus 2a plus 10. And the minus 10 plus 10 cancel. And that's all over x minus a. So we need to continue in the process of trying to factor and cancel. So we get 3x squared. I'm going to do something weird here. I'm going to move the 3a squared next. then the 2x. I'm just reassociating associative properties. Now, you probably didn't do this much, but in algebra there's something called factor by grouping. I grouped these two together because they both have a 3, and I grouped these two together because they both have a 2. Now I'll factor each one of those. Take the 3 out, I have x squared minus a squared. I take the 2 out, I have x minus a over x minus a. And you might think, what does that do for us? Well, I'm going to keep going. This is a crazy problem, lots of algebra, but you should recognize x squared, a squared, difference of two squares. That factors nicely to x minus a, x plus a, all over x minus a. And then you should notice they have a common factor. They both have an x minus a. Well, I'm going to take that out, x minus a out of that, and what's left? We have a 3, x plus a, and a 2. So what I did here is I took this out in front, so I'm left with 3 and x plus a. And then I take the x minus a out of there, and I'm left with a 2. So that's what's happened. It's called factor by grouping. And look, x minus a is canceled. Beautiful. And now we're going to finish this problem. We have 3x minus a plus 2, but x is approaching a, so that becomes a, oh, it's plus, scared me, plus, so this will end up to be, this is f prime at a, will be 3 times 2a plus 2, which is 6a plus 2. And if you'd rather write it with x's, you could do this, and we are done with that derivative, 6x plus 2. The tangent lines, you can look at the first two examples for those, and that's it. We are done. Bye-bye.